June 15, 1943, 25,000 feet above the English Channel. German ace pilot Klaus Briner squinted through his message canopy at the approaching American formation. 8 P-47s, those fat, lumbering, flying milk bottles the Luftwaffe had been swatting from European skies for months. Briner smirked. The Thunderbolts climbed like loaded freight trains, maxing out at barely 1,500 feet per minute, while his 109 could dance circles around them in a vertical fight. This would be another easy kill. But as Briner pulled into his attack dive, something impossible happened. The lead P-47 didn't try to run or turn away. Instead, it pitched up into a climb so aggressive it defied everything Luftwaffe intelligence knew about American fighters. The massive aircraft clawed skyward at nearly 2,000 feet per minute, its engines screaming at full power, chasing Briner into his own domain. In the cramped cockpit of his Messerschmitt, the German pilot felt his first taste of fear as the stupid American propeller 13 feet of revolutionary paddleblade engineering turned the sky's biggest joke into its most terrifying predator. Frank Caldwell studied the same reports from his cramped office at Hamilton's Standard Division. But where military commanders saw failure, the veteran engineer saw physics. The P-47 was not flawed in spirit or engineering. It was simply a beast of a machine bound by immutable laws of mass, drag, and thrust. Its radial engine, a marvel of robust design, produced enough horsepower to hurl the aircraft across the European sky. But pushing that bulk upward rapidly was another matter entirely. Caldwell traced his finger along the graphs and charts sprawled across his desk. Seeing what the pilots only felt, momentum was a cruel master. The Thunderbolt isn't losing battles, he muttered under his breath. It's being asked to fight in a manner it was never meant to. He imagined the P-47 climbing in a perfect arc. Propeller biting the wind, its 8.50 caliber guns ready to unleash devastation, but restrained by gravity itself. Caldwell's mind raced with potential solutions. Propeller pitch adjustments, weight redistribution, even minor tweaks to the supercharger to squeeze more life out of every cubic inch of air. The challenge wasn't to remake the plane. It was to let the plane fight the way it was strongest across the theater. Colonel Johnson was already receiving urgent requests from his pilots. Transfers, temporary leaves, and whispered mutterings about Jug suicides underscored the frustration. Yet somewhere in a workshop thousands of miles away, a man who understood engines better than most understood, human fear began to chart a path that might turn the Thunderbolt's weakness into its ultimate weapon: endurance. Firepower and resilience no lighter. Faster plane could match. Caldwell sketched the outline on a scrap of drafting paper. Aware that anyone else would have laughed at the suggestion, the broad-bladed propeller looked ungainly, almost ridiculous. But on paper, the physics were undeniable. The wider surface area would move more air per revolution, keeping the tip subsonic and maintaining lift even at full throttle. The engine's 2,300 horsepower would finally be translated into something usable: vertical climbs, rapid acceleration, the ability to meet the Messerschmitts on equal footing. He could almost see it in his mind. The Thunderbolt, no longer lumbering and hesitant, ripping up through the clouds. Its new, paddle-like propeller roaring like a mechanical beast. Each revolution would carry the plane upward with a brute force that no traditional thin-blade prop could hope to match. Combat would no longer be dictated by what the aircraft could endure, it would be dictated by what it could unleash. Yet, Caldwell knew the obstacles weren't just aerodynamic. Manufacturing tolerances, metal fatigue, vibration harmonics, every conceivable mechanical nightmare threatened to ground the idea before it ever left the drawing board. But the P-47's pilots were already paying with their lives for the limitations of convention. That thought hardened Caldwell's resolve. If physics had given him a solution, the Thunderbolt would rise, even if it meant rewriting every rule about what a propeller should look like. The next step was clear: convince the brass. Secure the resources and test the monstrosity in the air. Only then could the Jug shed its reputation as a lumbering, vulnerable target and become the airborne juggernaut it was always meant to be. The Army Air Force's procurement officers weren't engineers. But they understood money and schedules, and both Caldwell and Hayes' proposals were problematic in different ways. Hayes promised incremental improvement with minimal disruption, while Caldwell promised a revolution with every ounce of risk it entailed. The brass called it a high-stakes gamble in memos. Though to Caldwell it was simple arithmetic and physics, Caldwell spent nights in his cramped office, sketching variations on the paddle blade design, tweaking pitch angles, and running simulations on paper. He imagined the Thunderbolt surging upward, all 7 tons of it defying gravity with newfound ferocity. Every calculation confirmed the same truth. If he could convince the military to commit, the Jug could climb faster than any Luftwaffe fighter. The turning point came during a meeting at Wright Field. Caldwell laid out his numbers, each figure punctuated by the murmurs of disbelief and occasional grudging admiration. He framed it bluntly. We can continue producing more of the same more we can give our pilots a fighting chance. The room fell silent. The weight of lost airmen, the grim morning reports, and the stubborn logic of physics pressed down on every officer present. After tense deliberation, the Air Forces agreed to a limited prototype program. Hamilton's Standard would build a single test propeller 13 feet of paddle-bladed brute force, while the Army promised a P-47 test aircraft. It was a compromise. Risky enough to satisfy Caldwell, conservative enough to placate Hayes in the procurement. Brass. Caldwell left the meeting with a mixture of exhilaration and dread. The theoretical calculations had been validated on paper, but real air was another matter entirely. One test flight would determine whether the Jug would finally rise or crash under the weight of ambition. The Wright Field airstrip buzzed with anticipation on that early September morning. Ground crews moved with practiced precision, inspecting the P-47D fitted with Caldwell's paddle blade propeller. The massive blades gleamed in the sunlight, looking almost absurd to the untrained eye, thick, broad, and clumsy compared to the slender, elegant props of conventional fighters. Yet to Caldwell, they were instruments of potential salvation. Colonel Johnson paced along the tarmac, his brow furrowed. The numbers from Hamilton's Standard promised a dramatic improvement in climb rate and acceleration. But projections on paper had a notorious habit of failing once wind, vibration, and pilot reflexes entered the equation. He watched as the test pilot, Lieutenant Frank Hawk Morrison, climbed into the cockpit. Morrison's reputation for steady nerves and fearless judgment made him the natural choice for the first flight. Across the Atlantic, Major Wilhelm's report sat on the desks of Luftwaffe planners. He had dismissed the P-47 as a lumbering, easily exploited machine, but he did not know that. American engineers were rewriting the rules of propeller physics in secret workshops. If Caldwell's design worked, the Jug's weaknesses would be erased, replaced by a sudden verticality and raw thrust the Germans had never anticipated. With a final check of the instruments, Morrison advanced the throttle. The R-280 engine roared, and the thick paddle blades bit into the air. The P-47 lurched forward, heavy yet purposeful, and then remarkably began to climb, faster and more smoothly than any standard P-47 ever had. Colonel Johnson's jaw tightened as he watched the plane ascend, vertical and unhesitating, like a mechanical leviathan claiming the sky. For a brief, electrifying moment, the centuries of aerodynamic convention seemed irrelevant. Physics, raw and unapologetic, had been harnessed to save lives and alter air combat itself. The September tests at Wright Field were only the beginning, but already the tide of the war in the skies of Europe seemed a little less inevitable, a little more within America's grasp. Caldwell's jaw tightened as he studied the flight report. The paddle blades had proven their raw power vertical climb rates and acceleration, far beyond any standard P-47, but the airframe trembled under the load. Every rivet and bulkhead had been stressed in ways no previous flight had induced. The vibrations weren't just annoying. They were a direct threat to structural integrity. In the makeshift lab at Wright Field, engineers pored over strain gauges and oscillograph readings. The paddle blades had introduced harmonic frequencies that resonated with the fuselage and wings, amplifying the R-2800's torque into a destructive chorus of shaking metal. The solution would require recalculating blade thickness, mass distribution, and pitch to dampen the dangerous oscillations without. sacrificing the thrust that made the design revolutionary. Captain Anderson, normally stoic, was unusually candid during the debriefing. "The plane climbs like a rocket, Frank," he said, nodding at Caldwell. "But I've never felt a fighter shake like that." "You don't just fly it, wrestle it." Caldwell allowed himself a grim smile. This was exactly the kind of problem he had been hoping for. Solvable. But only through ingenuity, testing, and precision engineering. The raw power was there. Now it was a matter of taming it. He already had ideas. Slight modifications to blade root stiffness, introduction of tuned vibration dampers, small changes to the spinner and hub geometry to disrupt destructive harmonics. Each adjustment would be painstaking, but if successful, the P-47 would emerge not just stronger, but a machine that exploited physics rather than being constrained by it. As ground crews rolled the aircraft back to the hangar, Caldwell's mind was already racing through calculations. The October 12th flight had revealed the Achilles heel of the paddle blade concept, but it had also proven its promise. In the coming weeks, Wright Field would become the crucible in which America's most underestimated fighter would be forged into a predator the Luftwaffe had never imagined. Caldwell sat in the Wright Field control tower, rubbing his temples. The vibration issue was solved, yes, but the paddle blades were failing to deliver the raw thrust he had calculated. The heavier hub and forged shanks had tamed the oscillations, but at a cost. The added weight and subtle aerodynamic drag sapped much of the potential performance gain. Anderson, ever pragmatic, debriefed calmly. "It flies clean now, Frank. No shakes, no nerves of steel required. But it climbs only marginally faster than a standard P-47. I hate to say it. Curtis's refined narrow blade looks better on paper, and I think it flies better too." Caldwell's jaw tightened. He knew Hayes would relish this moment. Curtis Electric had taken the safer path, the Lorisk route. And the Army brass loved Lorisk numbers they could put in reports. Hayes' narrow blade propeller had been incrementally larger, slightly optimized in pitch, and fully compatible with existing hubs. Conservative, engineering, predictable, reliable, quick to deploy. Yet Caldwell couldn't abandon the paddle blade concept. He had seen what it could do in theory, and he refused to let the physics go untapped. There were still avenues left to explore. Subtle adjustments in blade camber, tip tapering, and hub dampening could restore lost performance without reintroducing destructive vibrations. It would take patience, ingenuity, and resources the Army might be reluctant to grant. Across the corridor, Hayes was already calling in his military contacts, confident that the Army would favor a quick, incremental victory over a protracted gamble. Caldwell leaned back, staring out at the airfield, watching the standard P-47's taxi past. The jug might be slow to rise, but he was determined that it would rise, and when it did, no amount of conservative thinking or bureaucratic caution could stop it. The engineering challenges went beyond mere pitch control. The broader paddle blades introduced new aerodynamic loads that stressed the hub and spinner in previously untested ways. At extreme fine-pitch settings, the massive blades generated a twisting moment that threatened to overload the strengthened hub. Hydraulic pressure had to be carefully regulated to avoid oscillations, and the governor's system had to respond faster than anything previously installed on a fighter aircraft. Even minor delays or overshoot could produce destructive flutter, which Caldwell knew could rip the propeller from the nose in an instant. Caldwell oversaw the installation personally, checking tolerances and alignment with obsessive care. Every valve, bearing, and linkage was scrutinized, because this system would allow the P-47 to exploit the full potential of the paddle blades across the entire flight envelope. Once complete, the jug could be light on its wings during level flight, yet transform into a vertical predator when climbing to intercept enemy aircraft. By the end of November, the modified P-47 was ready for another test. The ground crews had reinforced engine mounts, tightened all fasteners, performed exhaustive checks of the hydraulic governor. Caldwell, exhausted but resolute, watched as Captain Anderson climbed into the cockpit once more. The first test flight would determine whether all the painstaking modifications had finally aligned theory with reality, or whether the paddle blade concept was doomed to remain an Intriguing but impractical experiment as the engine roared to life. Caldwell felt the familiar mix of dread and exhilaration. This was no longer a mere test of a propeller, it was a test of whether bold engineering could rewrite the rules of air combat itself. Caldwell allowed himself a rare, satisfied smile as he watched the data roll in. The paddle blade propeller, once dismissed as impractical, had finally delivered on its promise. The combination of expanded constant speed pitch control and enhanced engine cooling had unlocked performance previously thought impossible for a 7-ton fighter. Anderson's maneuvers had proven that the Thunderbolt could now climb aggressively, engage enemy aircraft at altitude, and retain its legendary durability, all while carrying a full combat load. In the control tower, Lieutenant Colonel Johnson studied the figures with cautious optimism. The Pentagon's doubts about continued investment in the P-47 program had been based on numbers that now demanded revision. The Mustang was fast, yes, but it lacked the ruggedness, firepower, and all-weather resilience of the Thunderbolt. With the paddle blade modification, P-47 could fulfill a role no other American fighter could: a heavily armored, high-altitude fighter capable of confronting Luftwaffe aircraft on equal terms. Across the Atlantic, German intelligence would not yet realize the implications of Wright Field's tests. Major Wilhelm's reports had dismissed the P-47 as a lumbering, easily targeted aircraft. But if the paddle blade design entered production, the Jug would no longer be a predictable target. It would become a vertical predator, able to climb above enemy formations, bring its 8.50 caliber guns to bear with devastating accuracy, and survive hits that would cripple lighter, more delicate fighters. Caldwell knew the work was far from over. Further refinements to propeller geometry, blade aerodynamics, and engine management could push performance even higher. Yet for the first time, the math, the engineering, and the pilot reports were in harmony. The P-47's transformation was no longer theoretical, was real. The next step was clear: persuade the Army Air Forces to commit to full-scale production of the paddle blade. Thunderbolt, before bureaucratic caution or Pentagon politics could derail the program. If they succeeded, the American fighter fleet would soon take to the skies over Europe with a capability the Luftwaffe had never anticipated, into a reputation that would turn the Jug from a joke into a legend. For Caldwell, the contract for 50 paddle blade units represented both vindication and the start of a new challenge. The engineering hurdles of testing had been conquered, but production on a meaningful scale introduced its own complexities. Forged blade shanks, reinforced hubs, and the expanded constant speed governor all demanded precise manufacturing tolerances and rigorous quality control. Any mistake could turn a lethal weapon into a death trap for pilots. At Wright Field, teams worked feverishly to prepare the first batch of operational P-47 D-22s. Each aircraft was inspected with painstaking care. From the engine mounts to the spinner, from the hydraulic governor to the cooling louvers, test pilots like Anderson ran final systems checks, verifying that the paddle blades responded correctly across the full pitch range, and that dive recovery maneuvers could be executed without danger. Meanwhile, across the Atlantic, the Luftwaffe remained largely unconcerned. Major Wilhelm and his colleagues noted the modifications in intelligence reports, but their assessments were rooted in conventional thinking. The P-47 was a heavy brute, its size and weight unchangeable, and no propeller, however innovative, could alter its fundamental deficiencies. German pilots continued to fly standard interception tactics, confident that the Jug would remain a lumbering target. By early 1944, the first 50 paddle blade P-47s were ready for shipment. Colonel Johnson briefed his pilots with a mixture of caution and quiet optimism. The aircraft's reputation as a slow climber and poor dogfighter had been transformed. Now fully armed and armored, these Thunderbolts could climb aggressively, sustain high-altitude combat, and dive with confidence, all while maintaining the rugged survivability that had made the design beloved by ground crews. For Caldwell and his team, the true test was about to begin. Theory and controlled tests had proven the paddle blade concept, but the battlefield was the ultimate arbiter. The first encounters over Europe would reveal whether this radical engineering gamble could finally turn the jug from a curiosity into a fearsome predator of the skies. Gladdock ran his gloved hand along one of the thick, paddle-shaped blades, shaking his head. "This isn't a fighter propeller," he muttered in his clipped accent. "It's a windmill," round him. The other pilots of the 356th Fighter Group murmured their agreement. They had all heard the rumors that some engineer back in the States had fixed the Thunderbolt's climbing problem by bolting on oversized propellers, better suited for a bomber. None of them were eager to test the theory in combat. The maintenance crews were no less skeptical. The new propellers required careful balancing, recalibrated pitch governors, and stricter inspection schedules. Ground Chief Sergeant Ellison compared it to strapping a tornado to the front of a brick. Every one of the 50 aircraft would need careful tuning before it was airworthy. On March 18th, after 3 days of assembly and testing, the first flight trials began. Gladdock, ever the professional despite his doubts, volunteered to take the initial sortie. The new propeller spun up with a deep, heavy thrum that felt different even from inside the cockpit. As he advanced the throttle, the jug surged forward with unexpected urgency. The takeoff roll was shorter, the climb steeper. Within moments, the altimeter needle was rising faster than he'd ever seen it. At 15,000 feet, Gladdock leveled off, the roar of the R-2800 filling his headset. The aircraft felt alive in a way it never had before, responsive, aggressive, eager to move. He nosed over into a dive, pushing the throttle full forward. The P-47 dropped like a stone, building speed past 480 miles per hour. When he pulled back on the stick, expecting the usual sluggish response, the jug answered immediately, pulling out clean and steady. No buffet, no hesitation. The big fighter simply obeyed. When Gladdock taxied back to the flight line, a crowd had already gathered. He removed his oxygen mask and grinned a rare sight. "She climbs like a Spitfire," he said simply, "and dives like the devil." The skepticism vanished almost overnight. Within a week, word spread across the 8th Air Force that the new Thunderbolts were performing far beyond expectations. Reports from escort missions over northern France spoke of P-47s that could now meet FW-190s head-on in vertical climbs and survive the engagement. The Germans had no idea that their flying refrigerator had evolved into something far deadlier. He reacted instinctively, rolling inverted and pulling the jug into a climbing turn to meet the attack head-on. In the old Thunderbolt, such a maneuver would have been suicidal. The aircraft would have wallowed, bleeding airspeed until the German fighters carved it apart. But this time, something was different. The massive propeller bit into the thin air like a saw blade into wood. The P-47 surged upward with a force Gladdock had never felt before. The altimeter spun, the canopy rattled, and for the first time in his combat career, he was climbing with the Messerschmitts instead of watching them disappear above him. The German leader, a veteran ace from JG-26, expected the Americans to break formation and dive for safety. Instead, the Silver Thunderbolt came straight up to meet him, guns already flashing. The closing speed was tremendous. Gladdock's 6.50 caliber Brownings ripped through the lead 19's fuselage, sending it tumbling out of control in a burst of flame. The sudden reversal stunned the German formation. Their practiced high-altitude ambush had failed in the opening seconds. Below, the bomber crews saw something they'd never witnessed before. Thunderbolts climbing to engage enemy fighters rather than diving away. Radio chatter crackled with disbelief. "Look at those jugs go. They're chasing him up." Gladdock's wingman, Lieutenant Rayner, pushed into a vertical roll, following two 109s attempting to escape upward. The paddleblade prop kept the big fighter's nose climbing, even as airspeed bled away. At the top of the loop, Rayner squeezed off a short-burst 109 disintegrated. The other spun away, trailing smoke. The air battle raged for less than 5 minutes, but its implications were immense. When the surviving German pilots returned to base, their debriefs were filled with confusion. The Americans had somehow made their heavy escort fighters climb like interceptors. Intelligence officers dismissed the reports at first, assuming pilot error or misidentification. At Boxted, returning pilots of the 356th landed to an anxious crowd. Gladdock stepped down from his cockpit, his flight suit streaked with oil and frost, his grin unmistakable. "Tell Colonel Johnson," he said, "that his engineer just won us the sky." That day marked the turning point. Within weeks, the paddle blade propeller was no longer an experimental curiosity. It was a production priority. Hamilton's Standard received orders for thousands more, and by summer 1944, nearly every Thunderbolt in the European theater carried the distinctive broad blades that had transformed the Jug from an underperforming brute into the Luftwaffe's most dangerous opponent. Within days, pilots across JG-26 and JG-2 were trading rumors of a new American high climber. Thunderbolt that could meet a Messerschmitt head-on above 25,000 feet and live to tell about it. At first, squadron intelligence officers dismissed the stories as exaggerations. Every combat report seemed to grow in the telling. But the pattern was unmistakable. Encounters that once ended with American fighters diving for safety were now turning into sustained, high-altitude dogfights where the Thunderbolts held their own. By early April 1944, German reconnaissance photos confirmed that a new propeller type had appeared on front line. U.S. fighters, analysts at Rechlin studied the images with growing unease. The enormous blades looked crude, almost agricultural, yet reports from the front suggested they were delivering results no German engineer had thought possible. Luftwaffe technical officers initially argued that the heavier blades would create excessive drag and reduce maneuverability. Field reports soon proved otherwise. Pilots complained that the modified Thunderbolts could now climb through interception altitudes faster than expected, cutting off attacks before they could form up. At 8th Air Force headquarters, the reaction was immediate and electric. Colonel Johnson's desk was flooded with after-action reports praising the new propeller's performance. Squadrons that had once been reluctant to fly the paddle blade models were now demanding more of them. Engineering officers measured combat data, showing that the modified P-47s could reach operational altitudes 20% faster than before, while burning less fuel and clima. Remarkable efficiency gain for a design once criticized as overweight and engineered back at Hamilton Standard. Caldwell's team read the first dispatches in stunned silence. After months of failure, redesign, and ridicule from competitors, the numbers from Europe told the story more powerfully than any test report could. The barn door special had turned the tide. The same engineers who had spent Christmas nights recalculating blade pitch tolerances now realized they had altered the physics of the air war. Within weeks, production orders tripled. Factories in Connecticut and Massachusetts went to double shifts. Crates of paddle blade assemblies began shipping daily to modification centers across England. The transformation was so rapid that even veteran pilots struggled to keep up. By the time of the Normandy landings in June 1944, more than half of all Thunderbolts escorting Allied bombers carried the new propeller, symbol of American engineering, catching up to, and in some ways, surpassing German design philosophy. The discovery stunned the evaluators at Rechlin. German propeller technology had long been considered the pinnacle of aerodynamic refinement. Lightweight, narrow-chord blades optimized for efficiency and speed. Yet the Hamilton Standard paddle blade challenged every one of those assumptions. Its massive surface area was matched by a subtle twist gradient that varied continuously along the blade's length, optimized not by intuition or field experience, but by mathematical modeling and high-altitude airflow testing. Major Wilhelm Speck's engineers noted with growing discomfort that the Americans had achieved something the Luftwaffe's own design bureaus had been trying to perfect for years: consistent power conversion at extreme altitudes. The Germans had struggled with propeller efficiency above 25,000 feet, where air density fell to half of sea level values. Their variable pitch systems, derived from the VDM design lineage, worked well for the BF-109 and FW-1090 at medium altitudes, but suffered rapid thrust loss in the stratosphere. Caldwell's blade geometry, with its broader tip area and extended pitch range, compensated almost perfectly for that loss. The metallurgical analysis caused equal concern. The Hamilton blades were forged from a novel high-strength aluminum alloy containing trace elements of nickel and magnesium that provided exceptional fatigue resistance. German engineers still, relying heavily on duralumin and limited access to strategic metals, realized they could not easily replicate the alloy without diverting resources from critical aircraft engine production. The level of machining precisionally in the shank and hub assembly implied industrial tolerances far beyond what most German factories could maintain under wartime bombing and resource shortages. By mid-April, Speck's report reached the Reichslauffahrtdienst DRLM in Berlin. His conclusion was blunt. The new American propeller represents a fundamental advance in aerodynamic and metallurgical engineering. Its performance potential renders current assumptions about the Thunderbolt's limitations obsolete. The reaction within the RLM was divided. Some officers dismissed Speck's findings as alarmist, arguing that the P-47's weight and fuel consumption still made it inferior to the Messerschmitt and Focke-Wulf designs. Others, including technical advisor Oberst Werner Mulders, recognized the deeper implication. If the Allies could mass-produce such precision components, they might soon achieve parity or superiority in every performance category. Within weeks, Luftwaffe research units began experimenting with enlarged paddle-type blades for the FW-190D and TA-155D to series. But Germany's overstretched industrial base could not absorb the redesign. Production disruptions, material shortages, and Allied bombing ensured that none of these experimental propellers reached operational squadrons in time. By mid-May 1944, Luftwaffe commanders could no longer deny what their pilots were reporting daily. The American Thunderbolt, once derided as a lumbering brute, had become a formidable adversary. Mission debriefs from Jagdgeschwader 26 and 2 described repeated encounters where P-47 formations held altitude parity or even climbed through German interception layers. For the first time in the air war over Europe, German controllers could not guarantee their fighters the initiative of height and surprise. At first, reports were treated as anomalies. Perhaps the Americans had caught favorable weather, or their engines had been overboosted for short durations. But as engagement after engagement produced similar results, disbelief gave way to alarm. The very geometry of the air battle was shifting. Instead of diving attacks from the stratosphere, Luftwaffe pilots found themselves in level-turning fights, where the Thunderbolt's dive, acceleration, and durability gave it the edge. The new propeller had changed everything. The paddle blades allowed Thunderbolts to claw for altitude alongside their B-17s, intercept climbing German fighters before they reached firing position, and most critically sustain combat power. At heights above 25,000 feet, where the thin air had once neutralized American horsepower, what the Germans had thought a crude brute force design was now revealed as an instrument of industrial precision and aerodynamic audacity. LUFTWAFA. Intelligence summaries in late May carried a rare note of strategic pessimism. Enemy pursuit. Aircraft type P-47D. New propeller now demonstrate climb and ceiling performance equal to our Bf-109G series. Tactical doctrine requiring approach from altitude no longer ensures success. Within Allied command, the transformation was equally dramatic. Colonel Harold Ralph's 356th Group reported a 40% reduction in bomber losses during escort operations when paddle blade Thunderbolts were assigned. Pilots who had once dreaded the climb to altitude now reached bomber level with fuel and energy to spare. Frank Caldwell's name, once associated with an eccentric engineering gamble, began circulating quietly through Air Material Command as the man who had saved the Thunderbolt program. Hamilton Standard's production lines went into round-the-clock operation, retooling for thousands of new propellers. Some in Berlin insisted that the Americans must have introduced an entirely new engine or secret fuel additive. Others blamed exaggerated Allied propaganda. But engineers at Rechlin, the Luftwaffe's primary test center, knew better. They had dissected the captured Hamilton Standard propeller in minute detail. What they found was both infuriating and humbling. The Americans hadn't built a new fighter. At all, they had simply learned to extract the full potential from an engine the Germans already respected. The massive R2800 Double Wasp, long dismissed as an overpowered brute, had finally found the propeller it deserved. Recklin's analysts concluded that the paddle blade design achieved near-ideal power absorption, converting torque into thrust, with efficiency levels approaching those of experimental German variable pitch prototypes still years from operational readiness. By June 1944, Luftwaffe field reports spoke openly of a crisis in tactical doctrine. The Thunderbolt, once predictable in its limitations, had become erratic and dangerous. Pilots reported that the P-47s could now climb through their defensive spirals, outzoom from low-altitude fights, and recover from vertical dives with startling quickness. For the first time, Jagdgruppen leaders were forced to warn their men not to pursue Thunderbolts too aggressively at altitude. On the Allied side, morale soared as quickly as the new propellers bit into the air. Pilots who had once cursed the Jug's sluggishness began calling it the mountain climber. Reports from bomber crews over Berlin and Munich credited the paddle blade. P-47s, with breaking up Luftwaffe interception runs before they reached formation range. Even skeptical veterans like Captain Mike Gladdock admitted the transformation was real. "She doesn't wallow anymore," he told a combat reporter after a mission over Bremen. "You pull back on the stick now, and she just goes up like she's angry." The impact extended far beyond the front lines. The success of Caldwell's propeller ignited a wave of re-engineering across Allied aviation. Republic engineers began redesigning future P-47 models around the new propeller's torque curve, while North American aviation quietly commissioned Hamill's Standard to study paddle blade adaptations for the P-51 and F-6F programs. By summer's end, Frank Caldwell's name had become synonymous with one of the most dramatic transformations in modern military aviation, the moment when brute force met brilliance, and a misunderstood machine became a legend. As the Thunderbolts crossed the channel that morning, their broad-bladed propellers carved shimmering spirals of mist through the damp coastal air. Below them, the invasion fleet stretched to the horizon, an armada of steel and resolved, but it was the aircraft above that would decide whether the soldiers on the beaches lived or died. The Luftwaffe still had teeth, and every German fighter scrambled over Normandy would test not just Allied courage, but the engineering gamble that Frank Caldwell had fought to bring to life at 0600 hours. The first German interceptors appeared over small formations of FW-190s and Bf, 109 gigaseconds racing in from airfields near Dreux and Évreux. Their intent was the same as always: dive from altitude, strike the lumbering Allied bombers and transports, then disappear into the cloud layers before American escorts could react. But what met them instead were P-47s already waiting at equal height, turning smoothly into the attack, propellers flashing like scythes in the dawn light. For the Luftwaffe pilots, the shock was immediate. The Thunderbolts climbed with them, rolled with them, fought with them, something unthinkable only months before. In desperate vertical maneuvers, German pilots tried to spiral upward into the sun, but the paddle blade jugs stayed glued to their tails, roaring through 30,000 feet with power to spare. The old tactics of altitude supremacy were gone. Over the beaches, Allied troops would later describe the same sound again and again, a deep, rolling thunder that echoed over the invasion fleet. It was the P-47's double wasp at full power, paddle blades biting into the air as the fighters dove to strafe enemy positions and climb away before flak could find them. Every sortie proved Caldwell's triumph anew. The Thunderbolt could now climb as fiercely as it dove, turning its mass and might into total dominance of the skies. By midday, German air resistance had collapsed into scattered, isolated attacks. The Luftwaffe's once-dreaded interceptors were driven from the invasion zone, unable to regain the altitude advantage that had defined their success. The sky over Normandy belonged to the Allies, held not just by bravery, but by a 13-foot circle of aluminum and steel born in an engineer's imagination. Months earlier, Frank Caldwell's paddle blade propeller had done more than fix a flawed airplane. It had reshaped the very geometry of the air war. In that moment, as the Thunderbolts wheeled above the smoke and chaos of the beaches, the genius of engineering met the will of history, and for the first time in Europe, the Allies owned the sky completely. Major Klaus Matusch's Jagdgeschwader never reached Cannes in formation, at 10,000 feet, barely off their dispersal fields. His FW-190s were pounced upon by a roving screen of P-47s from the 56th fighter group Thunderbolts that had been loitering at medium altitude, waiting for just such a counterattack. What followed was not the clean, angular duel the Luftwaffe had trained for, but a brutal, twisting melee in which the Thunderbolts dictated every vertical move. Each time a German pilot tried to climb out of danger, the jugs followed. Their paddle blades biting into the dense morning air with effortless power, Matusha managed to break away briefly, diving toward the hedgerow-lined fields below. But the Americans dove faster, rolled tighter, and climbed out again before his wingman could regroup. When his fuel warning light flashed, he turned for home alone. Of the 12 aircraft he had let out, only 5 returned. His after-action report filed that evening was terse and uncharacteristically bleak. The Americans have achieved total parity in climb and altitude performance. Tactical initiative now lies with them. Recommend immediate withdrawal of FW-190 units from Western Front unless new propeller technology can be developed. In Berlin, Galland read the report in silence. For years, his entire doctrine had rested on altitude, on the premise that a skilled German pilot could always fight downhill. The paddle blade Thunderbolt had erased that truth in a single season. Meanwhile, over the invasion beaches, Gabreski's 56th Group ranged freely. His pilots strafed German convoys, shredded flak batteries, and silenced coastal guns that threatened the landing zones. When the few surviving Luftwaffe patrols appeared over the front, they were driven off within minutes. American pilots marveled at how effortlessly their heavy Thunderbolts now climbed back to altitude after a diving run. What had once been a slow, grinding ascent was now a confident surge skyward, the paddle blades clawing the air with muscular grace. By midday, Gabreski's pilots were reporting what Allied commanders had scarcely dared hope for: complete air supremacy over Normandy. The Luftwaffe had not merely been outfought, it had been out-engineered for the Luftwaffe pilots. It was a nightmare made real. Their training, their tactics, their very sense of superiority had been built on the idea that altitude equaled survival. In the early years of the war, a German fighter pilot who found himself below his opponent could simply open the throttle and climb away, his machine's power-to-weight ratio and propeller efficiency guaranteeing escape. But on the morning of June 6, 1944, that old truth evaporated in the thin air over Normandy. Captain Robert Johnson's 8 Thunderbolts climbed from sea level like nothing the Luftwaffe had seen before. The paddle blade propellers bit deep into the dense morning air, translating horsepower into lift with astonishing efficiency. Within 9 minutes, the American flight had risen through the haze and intercepted 24 Messerschmitt Bf-19s diving toward the Allied fleet. Johnson's wingman split into 2 elements and cut across the German formation at 18,000 feet. What followed was not a chase, it was an ambush, caught mid-descent. The German pilots tried to climb back out, but their engines screamed in protest. Thunderbolts followed, matching every maneuver, holding formation even as they rose in 2. Thinner air, where the Luftwaffe once held absolute advantage, tracers arced through the sky. One Bf-109 rolled inverted, its canopy shearing away before it plunged into the channel. 2 more disintegrated under concentrated .50 caliber fire from P-47 wing guns. Below, Allied naval crews cheered as the attacking formation broke apart and scattered inland. The sky above the invasion fleet, whence the 20 Luftwaffe's hunting ground, belonged to the Thunderbolts. The reports that evening left no doubt. The paddle blade propeller had done more than improve performance, it had rewritten the laws of engagement. The Luftwaffe could no longer fight from above, could no longer rely on energy advantage or altitude to dictate terms. Air combat over Western Europe had become a contest of endurance and firepower. In both, the Thunderbolt now reigned supreme. Galland's report that night was blunt. Stripped of the defiant optimism that had once colored Luftwaffe communications, the enemy now controls the vertical dimension, he wrote. Their fighters climb as we do, dive faster than we can. Follow and sustain combat at altitudes where our advantage once lay. We are tactically outclassed. Hermann Göring, seated in his command chair at Corinthal, refused to believe it at first. For years, it reassured Hitler that German technical genius would prevail, that the Reich's aircraft remained the finest in the world. But the messages arriving from Normandy left no room for interpretation. Unit after unit reported losses out of proportion to the scale of their engagements. Veteran pilots were being shot down in battles they should have dominated. The numbers from D-Day were catastrophic. Allied fighters flew 14,674 sorties. The Luftwaffe managed barely 289. Of those, fewer than 50 aircraft returned undamaged. The cause was not merely Allied numbers, it was physics. The new propeller design had erased the last. German advantage in the air. What had begun months earlier as a quiet engineering experiment in Connecticut had culminated in the collapse of an entire tactical doctrine built since 1940. Lieutenant Hansvik's combat report captured the essence of the disaster. His words, written in a trembling hand after surviving a running engagement with Thunderbolts over Cannes, became required reading for Luftwaffe staff officers. They climbed like rockets. I began my dive attack at 27,000 feet. The Americans followed through every roll and regained altitude faster than I could. There is no longer a safe height above them. By evening, Gallen's headquarters in Berlin had confirmed the unthinkable. The Luftwaffe no longer possessed operational control of the airspace over France. Without altitude superiority, interception of Allied bombers was nearly impossible. The once feared Jagdgeschwader wings were now reduced to defensive reactions, unable to challenge American formations with initiative or surprise. The transformation was total and irreversible. Frank Caldwell's paddle blade propeller had not only changed an airplane, it had shattered the strategic foundation of German airpower. Caldwell read the incoming reports with a mixture of disbelief and quiet satisfaction. Test data, combat reports, and pilot debriefs painted a picture far beyond anything laboratory simulations had predicted. The Thunderbolt's paddle blade propellers were no longer an experimental fix. They were the decisive factor in establishing Allied air supremacy over Normandy. The factory floor hummed with the rhythm of production. But the engineers and machinists working double shifts could scarcely comprehend the scale of what they had helped create. Each massive propeller they finished represented not just engineering skill, but lives saved and battles won thousands of miles away. Caldwell walked the assembly line, inspecting balanced blades, checking torque tolerances, and listening to his team's reports on minor adjustments. Everything he had risked months of redesign, countless arguments with skeptical colleagues, and a fortune in tooling and labor had paid off in the most dramatic way imaginable. By late evening, the news reached Washington. Pentagon analysts confirmed what the frontline report suggested: the paddle blade modification had enabled the P-47 to engage Luftwaffe fighters on equal terms at every altitude, protect Allied bombers more effectively than ever before, and even dictate the terms of combat in previously uncontested airspace. Strategic planners immediately requested accelerated production and retrofitting of all remaining P-47s, as well as investigation into paddle blade adaptations for other aircraft types. In Connecticut, Caldwell allowed himself a rare moment of reflection. The stupid propeller trick, once derided in meetings and memos, had done more than save a single fighter program. It had rewritten the calculus of air warfare over Europe. The Thunderbolt was no longer just a heavy, well-armored machine. It was a predator in its element, powered by 13 feet of aluminum ingenuity that had turned skepticism into legend. By the end of June 1944, the consequences of Caldwell's paddle blade innovation were clear across the European theater. The P-47 was no longer simply a support aircraft, it was a dominant, multi-role fighter capable of dictating engagements at every altitude. Allied commanders exploited this advantage ruthlessly. Bomber formations moved with reduced escort requirements. Ground attack missions faced minimal interference from enemy aircraft. And reconnaissance flights penetrated deeper into occupied territory with confidence. German industry and engineering struggled to keep pace. Analysis of captured propellers revealed that American metallurgists had combined high-strength aluminum alloys with precise blade geometry and variable pitch mechanisms to achieve efficiency levels unattainable with existing German materials or manufacturing tolerances. Even theoretical German designs could not replicate the combination of climb, speed, and durability that the Thunderbolt now offered. The Luftwaffe faced a stark reality. Without fundamental breakthroughs in both production capacity and propeller technology, their fighters would remain outclassed for the remainder of the war. On the operational level, German pilots who had once used altitude as a weapon now found themselves constantly reacting to American fighters that could follow them through climbs, dives, and rolls. Energy advantage, a cornerstone of Luftwaffe doctrine, had been neutralized. The psychological effect was profound. Veteran aces reported increased hesitation and defensive tactics, while inexperienced pilots faced near-certain attrition when encountering paddle blade-equipped Thunderbolts. For Allied air and ground forces, this dominance translated directly into freedom of maneuver. The Normandy beachhead was secured with unprecedented air cover, allowing ground units to advance inland without fear of German aerial interdiction. Subsequent campaigns across France, Belgium, and into the Rhineland saw similar patterns. Wherever paddle blade P-47s operated, the Luftwaffe's ability to influence the battlefield was sharply diminished. In essence, Caldwell's propeller had done more than enhance a fighter, it had rewritten the strategic calculus of the European air war. By converting raw horsepower into usable thrust at all altitudes, the Americans had turned a previously underperforming aircraft into a weapon that could challenge, and often surpass, Germany's best fighters. The paddle-blade P-47 became a symbol of industrial ingenuity, translating directly into operational dominance, a triumph of engineering that reshaped the course of World War. II de Caldwell allowed himself a rare moment of quiet satisfaction, letting the numbers sink in. Each paddle-blade propeller represented not only an engineering achievement, but lives saved, missions won, and airspace secured. The Thunderbolt, once dismissed as clumsy and underperforming, become a symbol of American ingenuity, endurance, and industrial might. The impact extended far beyond statistics. Pilots who had once feared climbing engagements now leveraged their aircraft's newfound power to dictate the terms of battle. Veteran aces like Gabreski credited the paddle blade P-47 with giving them the edge that turned attrition into dominance. Ground operations, once vulnerable to Luftwaffe harassment, now advanced with confidence under a protective canopy of Thunderbolts. Post-war, Caldwell's work became a case study in engineering audacity and risk. Hamilton Standard's production techniques, refined to meet the demands of paddle blade manufacturing, influenced aircraft design and industrial processes for decades. Future high-performance piston aircraft, and even early jet designs incorporated lessons from the careful translation of engine power into effective thrust.
Principal Caldwell had proven decisively.
The legend of the flying milk bottle was transformed. It was no longer a joke among Luftwaffe pilots or a source of American embarrassment. The P-47 Thunderbolt, equipped with 13 feet of revolutionary paddle blade engineering, had altered the course of the air war in Europe, proving that vision, persistence, and a willingness to challenge conventional wisdom could literally reshape the skies. Represented a profound shift in the human calculus of the air war, where once the skies over Europe had been a deadly lottery where even skilled pilots risked being outclimbed. Outmaneuvered or outgunned, the paddle blade P-47 transformed survival into a measurable, repeatable advantage. Each Thunderbolt sortie carried not just the potential to destroy enemy aircraft, but the certainty that trained American pilots could exploit their aircraft's full performance envelope with confidence. For pilots like Lieutenant Johnson, the paddle blade propeller was more than a piece of hardware, it was a literal lifeline. The climbs that once left them vulnerable to Messerschmitts and Focke-Wulfs now became opportunities to dictate engagement. Retreat safely when necessary, and return to fight another day. Across the 8th and 9th Air Forces, hundreds of aviators credited the modified Thunderbolt with their ability to survive and succeed in missions that would previously have been considered near-suicidal. The operational consequences extended far beyond individual survival. Allied air dominance over Normandy, the Low Countries, and eventually the Reich itself was cemented by aircraft that could now climb, dive, and fight at will, neutralizing the Luftwaffe's historic advantage in altitude and energy tactics. German engineers confronted with the captured paddle blade designs acknowledged in private reports that they could not replicate the technology at scale before the war's end. The advantage was absolute and unbroken. The paddle blade P-47 remained an exclusively American tool of air superiority. By the war's conclusion, Frank Caldwell's innovation had achieved something remarkable. It had saved lives, multiplied the effectiveness of Allied air power, and rewritten the tactical rules of engagement. The 13-foot blades that had once seemed a ridiculous, impractical idea had delivered a decisive technological edge, proving that ingenuity and courage in engineering could alter the course of history itself. The ripple effects of Caldwell's innovation extended deep into post-war aviation thinking. By demonstrating that thoughtful exploitation of engine power through optimized propeller design could overturn long-held tactical assumptions, the paddle blade P-47 set a new benchmark for American aeronautical engineering. Designers began approaching aircraft not as static compromises between speed, climb, and maneuverability, but as systems where every component, propeller, airframe, engine, and controls could be tuned for maximum integrated performance. In practical terms, the paddle blade's success influenced every high-performance piston aircraft in the final stages of the war. The North American P-51H incorporated wider, more efficient blades to better absorb its Rolls-Royce Merlin engine's torque, while the Republic P-47N's extended range variants leveraged the concept to maintain performance at long-distance escort missions in the Pacific. Even experimental post-war fighters and early turboprops borrowed principles first proven on Caldwell's Thunderbolt, managing engine output through larger, carefully balanced propellers to maintain energy advantage across a full flight envelope. Strategically, the paddle blade transformation had redefined air power doctrine. The Luftwaffe's inability to contest the skies meant that Allied air superiority became absolute, allowing ground operations to advance without the constant threat of interdiction. Caldwell's invention had not only preserved lives in one battle, it had demonstrated that engineering ingenuity, combined with industrial capacity and materials science, could decisively reshape the outcome of modern warfare in the annals of aviation history. The 13-foot paddle blade propeller stands as a testament to the power of daring ideas executed with precision, a small component whose impact reached across continents and altered the course of World War II. Caldwell's contribution became a benchmark for the synergy between innovative engineering and industrial capability. The techniques honed in producing thousands of paddle blade propellers advanced metallurgy, precision forging, dynamic balancing, and rigorous quality control transferred seamlessly into civilian manufacturing. From automotive components to turbine production, the paddle blade program had trained an entire generation of engineers and machinists to think in terms of system-level performance rather than isolated component optimization in aviation. The influence of Caldwell's design philosophy persisted long after the last combat P-47s were retired. Post-war fighter and transport aircraft incorporated lessons from the Thunderbolt. Larger, carefully profiled propellers for piston engine designs, and an emphasis on integrating engine and propeller characteristics with airframe aerodynamics to maximize thrust, climb, and overall efficiency. Even as jet propulsion began to dominate the skies, the fundamental principle matching power output to usable thrust across the flight envelope remained a guiding concept in propeller-driven and early turboprop aircraft design. Historically, the paddle blade P-47 was remembered not merely for its combat record, but for its transformative effect on Allied air strategy. By eliminating the Luftwaffe's altitude advantage, it allowed Allied forces to maintain operational initiative, reduce casualties, and accelerate the liberation of occupied Europe. For Frank Caldwell, the White House ceremony was symbolic. The real measure of his success was the countless lives saved and the decisive edge he had provided to American air power. His 13-foot innovation had proven that bold, unconventional thinking backed by rigorous engineering and industrial commitment could change the course of history. By the fall of 1945, the ripple effects of Caldwell's paddle blade innovation were visible far beyond military aviation. Factories once devoted to churning out 13-foot propellers for the European theater now applied the same precision, engineering, and metallurgical techniques to civilian aircraft, producing larger, more efficient propellers for transport planes and emerging commercial airliners. The lessons learn how to convert raw engine horsepower into usable thrust, how to balance strength with minimal weight, and how to maintain performance across a wide range of operating conditions formed the foundation for a new era in aeronautical engineering. Automotive and industrial sectors benefited as well. The alloys, forging processes, and dynamic balancing techniques developed for the paddle blades improved engine reliability and efficiency in cars, trucks, and turbines. American manufacturing had been accelerated by years, giving post-war industry a competitive edge that extended beyond the skies. Strategically, Caldwell's achievement reinforced a timeless principle for military planners. Technological advantage is often less about entirely new inventions than about inventive application of existing capabilities. The P-47 Thunderbolt had already rewritten the rules of aerial combat. Now, its underlying innovation was seeding prosperity and progress in peacetime. Broadblade propeller technology, once a desperate gamble in a wartime laboratory, was becoming the engine of American commercial and industrial dominance. Testament to how one bold idea could reshape both war and peace. In the end, the story of the paddle-blade P-47 was not merely one of numbers, tactics, or even battlefield heroics. It was a testament to the power of inventive engineering to alter the course of history. Captured German pilots, from seasoned aces to career officers, acknowledged in post-war interviews that the appearance of paddle-blade-equipped Thunderbolts had marked the irreversible decline of Luftwaffe air dominance. Major Klaus Meidisches remarked that these aircraft ended our war in the air, echoed a truth recognized quietly by all who had faced them. Frank Caldwell's final wartime report, understated as ever, masked the full magnitude of his achievement. What began as a seemingly impractical, stupid propeller trick had grown into a decisive technological advantage that transformed American air power. The paddle-blade propeller demonstrated that effectiveness, how well a system performed under real-world conditions, could outweigh conventional notions of efficiency or elegance. It showed that bold, unconventional ideas, backed by rigorous calculation and persistent refinement, could overcome entrenched assumptions and reshape entire fields of endeavor. The legacy of those 13-foot blades endured far beyond the skies of Europe. They informed post-war aviation, influenced the design of commercial airliners and transport aircraft, and provided a template for American engineers approaching the challenges of the jet age. More than just a technical solution, the paddle-blade propeller became a symbol of engineering courage, illustrating that innovation, when combined with vision and determination, could turn a modest machine into an instrument of strategic transformation. In proving that Caldwell had done far more than improve a single fighter, he had rewritten the rules of what was possible in aviation itself.